So our task today, we've been given three vectors that are in magnitude and direction format. Magnitude of the first vector is 20 and the direction is 188.5 degrees. And we've been asked to convert these vectors into component forms. So in other words, we want to break this vector from, say, a speed in a direction or a distance in a direction into an x and a y component. Well, there's a real simple way to do that. As we developed in class, you'll find that the x component of a vector is always the vector times the cosine of the angle. And the y component is always the vector times the sine of the angle. Now, given that information, here is the vector. That's the f. That's the magnitude of the vector. So to find the x component, I'm just going to plug into this formula. F of x equals 20 cosine 188.5 degrees. And if I type that into my calculator, I'm going to get negative 19.780. And if I type this one, Fy equals 20 sine 188.5 degrees into my calculator, I'm going to get negative 2.956. Now, that's the x component, that's the y component. The last thing we need to do is list these properly, which is to put them in what I like to call pointed parentheses. That's how you know it's a component form of a vector. This is when it's listed like that. So it'll be negative 19.780, comma, negative 2.956. X, then Y, just like plotting a point. Now, the only other thing I like to check is if you look at theta, theta is 188.5. 188.5 is in quadrant 3. Look at your components. You went left 19 and down 3. That would be in quadrant 3. So the angle matches the components, and that's what we always want to look for. Does our answer make sense? So let's look at the second vector, vector A. It says the magnitude of vector A is 15. The direction angle of vector A is 242 degrees. So we need to find the components. Well, again, the x component is going to be the vector times the cosine of theta. So that's going to be 15 cosine 242. And 15 cosine of 242 is negative 7.042. Okay? The y component will be the vector times the sine of theta. So the y component will be 15 times the sine of 242. And 15 sine 242 is negative 13.244. So there are the components of vector A, and then we just need to write them in the proper format, negative 7.042, comma, negative 13.244. And again, the x vector first, the y vector second. And again, I like to look at this. 242 degrees would be in quadrant 3. And where is x and y both negative? Also in quadrant 3. So our answer makes sense. On to our final vector here, vector M. The magnitude is 13. And the direction angle is 1,385 degrees. Okay, so the x component of this vector will be the magnitude, 13, times the cosine of the direction angle, 1,385 degrees. And if I multiply that, I get 7.456. The y component will be the magnitude, 13, times the sine of theta, 13.1385 degrees. And when I multiply that, I get negative 10.649. So this vector is going to be 7.456, comma, negative 10.649. I like to double check. X is positive, Y is negative. That is a quadrant 4 vector. Now, 1385. I don't know what quadrant that's in. But if I subtract 360, and I subtract 360, and I subtract 360 again, I come up with 305 degrees. So this is coterminal to 305 degrees. Well, 305 degrees is in quadrant 4, and this vector is also in quadrant 4. So again, I feel like my answer makes sense. If you have any questions, please come see me.